Okay, in a previous video we listed all of the possible rational roots of this equation, and I still have those listed up here. Now we want to take that one step further. We want to find the actual ones that are roots. So we want to take from these 12 possibilities, we want to see if any of these are actually roots. Right? So far we don't know if they are, we just know these are the only possibilities. So what we're going to do is we're going to use a combination of synthetic division and the remainder theorem to test these, looking to get a remainder of 0, meaning that this function would have evaluated to 0, which made it a 0 of the function or a root of the equation. So let's just start testing these roots and see what happens. If you have a graphing calculator, I really might recommend that you graph the function and kind of look at where it appears to cross the x-axis and narrow it down to which ones you think maybe you should test that are near that. But I'm going to do this the old-fashioned way, assuming that I don't have a graphing calculator. I do, but I don't know if everybody watching this does. So we're going to go ahead and take some time, cycle through these, and show you how you would test these if you don't. So let's go ahead and start off setting up our synthetic division problem. And let's go ahead and let's say we want to test positive 1 first. So we'll put positive 1 in the box. List my coefficients of 7, negative 2, negative 14, and 4. And try to cycle through this synthetic division process. Again, drop the 7 down. 1 times 7 is 7. Add the column. Negative 2 and 7 makes 5. 1 times 5 makes 5. Add the column right there. I get negative 9. And 1 times negative 9 is negative 9. And add the column right there, and I get negative 5. I didn't get 0. So 1 is not a root of this equation. So let's back up. So far we've exhausted 1. It didn't work. So I'm listing them over here. 1, nope. Now let's try negative 1. Let's see if it works. Let's put negative 1 in the box, and let's cycle through this synthetic division problem. Drop down the 7. Negative 1 times 7 is negative 7. Add the column. I get negative 9. Negative 1 times negative 9 is positive 9. Add the column. I get 5. I get negative 5. Negative 1 times negative 5 is 5. Add the column, I get 9. I didn't get 0. So negative 1 is also not an actual root to this equation. This is going to take a while if you don't have a calculator. As you can tell, there are 12 things involved. There are 12 options, and we've tested 2 of them. Right now we're 0 for 2. There's 10 left. Let's try positive 2. Drop the 7 straight down. 2 times 7 is 14. Add the column there, that's 12. 2 times 12 is 24. Add the column there, that's 10. 2 times 10 is 20. Add the column, that's 24. Nope. Back up. Try a different one. Let's try negative 2. Drop the 7. Negative 2 times 7 is negative 14. Add the column there, that's a negative 16. Negative 2 times negative 16 is 32. That gives you 18. With that, and that 2 times negative 18 is negative 36. And add your column there, that's negative 32. Either way, not 0. So that didn't work. We having fun yet? Now let's try 4. Drop the 7. 4 times 7 is 28. Add the column there, you get 26. 4 times 26 is 104. Go ahead and add the column right there. You get 90. And I can stop now. I don't have to continue this all the way to the end and figure out what all these numbers are. As soon as I can see that this isn't going to get me to 0, That's going to give me 360 and then 364. As soon as you recognize, nope, this is quickly going the wrong direction, you might as well just stop and go back and try to test something else. So we tested 4, didn't get anywhere. Let's try -4. Let's see if that gets us anywhere. Drop the 7. -4 times 7 is -28. That gives me -30 when I add the column. -4 times -30 is 120. I don't know if you can see yet, but I don't think this is going towards 0 right now. Go ahead and add the column there, and I'm looking at 106. And I can see that this is getting out of hand as well. So I'm not going to continue. I'm going to go ahead and say, nope, that -4 did not work. I think you get the idea. I don't think I need to test every single one of these going until the end with this, just to get the point across in this video. I don't want it to become so boring that you don't know what to do. This will take a little bit of time if you don't have a graphing calculator. I do have a graphing calculator so that I can test this. So let me take a look at what that should look like really quick so that I know about where it is. Okay, so I can tell from looking at it, it's going to be one of these fractional values. It's going to be one of these positive fractions, either 1/7 or 2/7 from what I can see from the graph. That looks like the only place it appears to cross. This could be one of these possible choices here for the rational roots. So I'm going to go ahead and just try that. Let me try 2/7 in the box and see if I can cycle through this. This will test your knowledge of fractions a little bit. Let's drop the 7 down. 2/7 times 7 is just 2. Add the column there, I get 0. 2/7 times 0 is actually 0. Add the column right there, I get -14. 2/7 times 14 there, let's see, that'd be -28/7 for that. With that, and actually -28/7 can simplify. 7 goes into 28 4 times, so -28/7 is actually -4. And then go ahead and add the column there, and you get 0. Yay. So we've actually verified that 2/7 is a rational root to this equation. Again, I would need to consider testing the rest of them. Again, I recommend that you use your technology, graph it, take a look at where it looks like it might be close, and then test them. This is the only one that appears to work from this. I think if I continued to test all the rest of them, I tested up to 6 of them. I made it halfway there. I think if I would, and then I tested this one, so 7. I had 5 more that I could test. I'll go ahead and tell you right now that if I test those 5 more, they're not going to work because I already know what the answer should be. So this was the only one here. But you could certainly find multiple options from this list that do work on several problems.